Welcome. I'm Sean Shanley with Viridiant.
And I'm Andrew Grigsby with Viridiant.
And today we'll be talking about heat pump water heaters in the Southeast. Before we get started, we would love to get your feedback on today's training so that we can improve it for future audiences. We've provided a QR code so that you can take an anonymous survey if you have the time. If you're comfortable, there are also some questions on there to help us know what kind of folks we're reaching so we can understand who we're training and who might be missing. This is an introductory course on the upcoming market transformations in water heaters and should be used to help inform business owners and installers on basic background and to give you a sense of what you should ask for when you're making decisions. Our objective today is to provide you with an overview of the latest information and available resources. As professionals, you'll be selling, recommending, and hopefully installing heat pump water heaters for your clients. We want to make sure that you leave with useful facts about heat pump water heaters. Our goal is for you to be able to identify 3 technical or mechanical aspects of heat pump water heaters, 3 market factors relevant to these devices, 3 common myths and the pertinent facts, and 3 resources that professionals can rely on for information when talking to users, businesses, and consumers. These resources come from a number of different places, such as the U.S. Department of Energy. For our agenda today, we'll be going over a brief introduction to this project, talking through some technology and terminology for heat pump water heaters, covering several myths about heat pump water heaters, covering market and incentive information, code and installation information, and we'll wrap up with a brief activity. We're here today thanks to funding from the U.S. Department of Energy, which is intended to increase the market penetration of 4 technologies: heat pump water heaters, air source heat pumps, electric vehicle charging systems, and residential battery systems. These technologies were chosen because they have some of the greatest potential for energy savings, cost savings, and market growth. And we are required to include this statement: the views expressed herein do not necessarily represent the views of the U.S. Department of Energy or the United States government.
All right, thanks, Sean. To get started, let's talk about exactly how these devices work. We're going to outline some key terminology. UEF is the Uniform Energy Factor. It's the newest measure of overall water heater efficiency and replaces the old EF metric. It's meant to more accurately reflect real-world conditions. The higher the UEF value is, the more efficient the water heater. UEF is determined by the Department of Energy's test method, and is meant to be compared across water heaters in the same bin or group to judge the efficiency. First hour rating, FHR, is an estimate of the maximum volume of hot water in gallons that a storage water heater can supply within an hour that begins with the water heater fully heated. The FHR is measured at 125 degrees Fahrenheit outlet temperature in the Uniform Energy Factor test method. So how does a heat pump water heater work? Well, a heat pump is a device that moves heat from one place to another. A heat pump water heater moves heat from the surrounding space into the storage tank. Most heat pump water heaters operate as hybrid devices, meaning they use the heat pump functionality whenever possible, but there are built-in controls that switch on the conventional resistance heating when there are large hot water needs. Because they do exhaust cold air and pull heat from the space they're located in, consideration needs to be given to where in the home the heater is located. We'll talk more about that later. Similar to a heat pump and to a refrigerator, a heat pump water heater uses the refrigeration cycle to move heat from one place to another. One way to think about that is like a window AC being stuck on top of a storage tank. But instead of hot air being the waste product, it's the useful product. So the heat generated goes into the tank, and cold air is the waste product that gets expelled. These water heaters typically have 3 modes of operation: electric resistance, hybrid, and heat pump. The electric resistance mode operates the water heater in a standard electric resistance only mode, just like conventional electric tank water heaters. The hybrid mode is how we refer to those times when both the electric resistance heat and the heat pump technology are working to provide heat to the tank. The heat pump only mode is when only the heat pump function is operating, which is the most efficient, but will take longer to reheat the water.
A heat pump water heater, sometimes called an HPWH, is a highly efficient water heating option. They have a UEF rating of greater than 2.0 and sometimes up to just over 4 UEF, compared to a 0.88 to 0.95 UEF rating that are typical for standard electric resistance water heaters. For some additional context, a 1.0 UEF would mean that the water heater is 100% efficient. So 2.0 or a 4.0 means that the water heater is 200 or 400% efficient. This is possible thanks to the refrigeration cycle that we talked about, since energy is used to do the work of gathering heat instead of being used to directly heat the water, like with an electric resistance water heater. The actual operating efficiency of a heat pump water heater is variable depending on the site-specific factors such as the temperature of the area it's installed in, as well as the mode it's being operated in. Heat pump water heaters are primarily designed as alternatives or replacements for standard electric resistance water heaters, but of course can also replace gas or oil water heaters. Fun fact, if somebody is looking to install an electric Energy Star water heater, only heat pump water heaters are efficient enough to earn the Energy Star label. As with all water heaters, heat pump water heater products currently available in the market range in tank volume, first hour capacity ratings, efficiency, as well as the physical size and weight of those water heaters. When selecting one, the first hour rating, FHR, which is listed in gallons, is probably the most important factor to consider. As noted before, the FHR is the amount of hot water that a water heater can deliver in a single hour when it starts off with a full tank of hot water. That FHR should be equal to or greater than the highest volume of water typically used during any hour of normal operation in the home. While hot water use varies widely from home to home, some guidelines for first hour ratings in typical homes are shown in this table. Along the top, you'll see the number of bedrooms, which functions as a proxy for the number of people in the home, and along the side you have the number of bathrooms, which is a way to get at the potential amount of simultaneous fixture usage. So you can use this to get an idea of the FHR that you should be looking for in a water heater. If you want to do a more detailed analysis, the U.S. Department of Energy has a website called Sizing a New Water Heater, which provides a worksheet to estimate those target FHRs specific to the home.
We wanted to talk about some of the common myths we've heard about heat pump water heaters and then cover the actual facts. First myth is that a lot of folks seem to think that heat pump water heaters are always going to be too big for their home.
It is true that traditional heat pump water heaters are slightly taller than a standard electric water heater. The footprint is comparable though. They'll still take up about the same amount of floor space. They're just taller. The reason that they're taller is because you've essentially stuck that window unit, the compressor, on top of the tank. There is the ability for some of these systems to be split, like you would see in a heat pump where there's an outside unit and an inside unit. There's one manufacturer that makes something like that. And in those cases, you could just have a standard size storage tank inside because the compressor sits outside. In that case, you'd have more flexibility into the size of that storage tank. Also, to take into account with the more standard heat pump water heaters, when you have the compressor on top, those have filters in them. A lot of the time the filter pulls straight up, so you need to allow for room to pull up that filter. Manufacturers will also provide dimensions to ensure that you have enough space around the water heater, so that's something else to look at as well. In terms of the weight of these are significantly heavier. Pulling up a random 50-gallon hot water heater, that's a heat pump one, that weighed in at 218 pounds, whereas the standard electric 50-gallon weighed in at 132 pounds.
So, taller and heavier, but otherwise very similar.
Yep.
So another thing we hear is that they make noise, that they're louder than a conventional electric water heater.
They are indeed louder because they do have that compressor that is sitting on top unless you happen to have gotten one of the split systems. So there is noise from that. It tends to be no louder than a refrigerator. Similarly to a refrigerator, it cycles on and off as needed to maintain the temperature in the storage tank. Manufacturers have definitely spent a lot of time and effort trying to minimize the sound transmission from these. That said, it is something where you probably don't want to put it very close to a cluster of bedrooms A lot of the time, the best locations for these are a basement or a garage or a similar space that's separated from the living area.
That sounds manageable. I never think about my refrigerator's noise.
No,
that's for
most
sure.
people don't.
Gotcha. Okay. So what about cost? People are asking how much these things cost, and maybe they're just way too expensive.
They are significantly more expensive than a standard electric water heater. But with the incentives that are available, which we'll talk about, and the savings that are recognized each year, they actually end up having a pretty quick payback time. The numbers on this table, they are for some example 50-gallon water heaters that anyone could pick up at a big box store today. And the annual operating costs are from the energy guide labels on those respective water heaters. So the heat pump water heater, with those savings, which are annual savings, would pay for itself with those savings in just over 3 years. With the utility rebates in the range of $300 to $400, coupled with the tax credits that are available for up to about 30% of the product through the IRA, that equipment pays for itself in even less time. As an added benefit, if you have a client that's interested in achieving net zero, meaning they're going to be putting PV panels on their home, if you're able to reduce the electricity cost, you have savings in how much PV you'd need to install to achieve net zero.
They do use a lot less energy, don't
Yes.
they? All right, so one last little detail. This word hybrid, we got used to hybrid as we were talking about hybrid vehicles years ago. Does that mean that these use gas some of the time?
Nope, it is just a marketing term and probably did draw on the success of using the word hybrid for hybrid vehicles. They are all electric. They're called hybrid because they can be all electric, they could be all heat pump, or they can be a hybrid of both, which is their optimal operating mode.
And the electric is, I mean, heat pump is still electric.
Yes.
You're talking about the electric resistance heat as
Yep.
the old school heat strips.
Yes.
Gotcha. All right, there's one more though. We talked about bringing cold air in. Are they difficult to install compared to a conventional electric tank?
There's a little bit more involved with their installation, but if you have the skills to install a standard electric water heater, you have the skills for a typical heat pump water heater as well. The main difference is running the condensate line. So just like your window AC drips out water, these also have water as a waste product, and so that condensate needs to be drained to somewhere. So a condensate line will need to be installed. They can be installed with ducting. They don't have to be installed with ducting. And what that ducting does is it either expels the cold air to a specific space that you choose, or you can pull in the outside air, the heat, from a specific space that you choose. So it allows you a little bit more flexibility with how the water heater is installed. So usually if somebody is used to doing plumbing work, they're used to doing HVAC work, it's the same materials, same installation specifics, just applied to a different piece of equipment.
Gotcha. And the ducting is optional. It really depends on the home and the client's goals.
Exactly. You'll always want to refer to the manufacturer's installation instructions just to make sure that where you plan to put it, it can work without ducting. In some cases it will be required, but there will be many spots where it's optional.
Okay. All right. Well, that was helpful. Let's talk a little bit about the market for heat pump water heaters and where we think that's heading over the next coming years. There are lots of options for water heaters. Tank, tankless, gas. People have real questions about this and about what's right for their home. And one of the things we're thinking about is how in a home, electrical service really is a given. And so you might ask, well, why pay for that additional fossil fuel infrastructure? And why pay those monthly fees if you can achieve the same purpose via an energy source that's already coming to the home? This chart from the U.S. Energy Information Administration shows trends in retail gas prices since the 1980s. As you can see, after remaining remarkably stable for more than a decade, methane gas, we're not talking about the gas at the pump for filling up your car, methane gases started creeping up with the onset of the global COVID pandemic. And then global price shocks caused by Russia's invasion of Ukraine made wholesale gas prices triple, and the entire world market started changing dramatically. Prices have come down since that peak, but now the relatively high cost and that historic volatility of gas and oil prices have motivated many folks to go all electric. That is, if the convenience, safety, cost, and performance of the all-electric equipment isn't reason enough. In a way, electricity price trends are similar to gas. Here, you can see that same spike in 2022 because so much electricity is generated at gas-fired power plants. Going forward, we expect electricity prices to be a little more stable as it transitions to renewable energy sources. That's because solar and wind power have no ongoing fuel costs. And they are not vulnerable to changes in global markets. Based on U.S. Census data going back to 2005, electric-only homes continue to gain market share across the entire country. As of 2015, 25% of U.S. homes were all electric. And here in the Southeast, nearly 45% of homes are all electric, which makes heat pump water heaters an excellent choice, as they already are heating their water with electricity. In new homes, it's just cheaper to forego the gas hookup and monthly service fees. For retrofit, most water heaters are installed in space where a heat pump water heater can fit. If a gas water heater is being replaced, it increases the safety of occupants by removing a potential source of carbon monoxide. And here's some recent data from all electric homes, broken out by state, so you can see more detail about how the Southeast leads the country in this trend. Overall, all these trends can be summed up in one word: electrification. As technology improves, energy markets change, and new energy sources become available, the economic and technological arguments for all electric homes just kind of pile up. And therefore, we're seeing the entire country moving towards all electric homes. The grid and buildings are increasingly powered by renewables, both on-site and off, with minimal operational costs and no rising fuel costs, plus no greenhouse gas emissions. We've seen how fossil fuel infrastructure will just get more expensive to maintain as users defect for all electric systems. And we've also talked about how electricity prices rising is often due to rising gas prices. But as renewables come online, those prices should stay more stable as there are no ongoing fuel prices. Overall, electricity offers greater price predictability for consumers. And finally, increasing awareness of indoor air quality risks compared to gas appliances is making a lot more people think about shifting to all electric. The two major markets for heat pump water heaters are single-family and multifamily residences, which, according to the Advanced Water Heating Initiative, currently account for more than 118 million water heaters. Of those, heat pump water heaters make up less than 1% of installations or sales, despite having a number of models available. If heat pump water heaters were to reach even 15% of the more than 25 million systems which are going to need replacement in the next 5 years, we could save 15.6 billion kilowatt hours per year. Water heating accounts for a large portion of a home's energy use, 19 to 32% on average, according to the Energy Information Administration. With the efficiency of heat pump water heaters, homeowners would typically see the water heating portion of their bill decrease by 2/3. In addition to saving energy, utilities can use heat pump water heaters as part of demand response programs. Heat pump water heaters provide similar load control options as resistant water heaters, but offer permanent reductions in energy consumption and a more gradual recovery after a peak power reducing event.
While the upfront costs of a heat pump water heater are higher than an electric resistance water heater, the annual operating costs are much lower. Additionally, there are incentives in the form of rebates and tax credits that many homeowners will be able to take advantage of to lower the purchase cost of a heat pump water heater, which we'll talk about later. But let's compare the energy label of two 45-gallon water heaters that you could pick up at a big box store today. The electric resistance one is 0.92 UEF and costs $489 per year to operate, assuming a rate of 14 cents per kilowatt hour. The heat pump water heater has a UEF of 3.88, over 4 times more efficient, and costs $117 per year to operate. Let's talk about preventative replacement, or shall we say preemptive. Sometimes water heaters can appear to be working fine and then fail without warning. Most times, though, there are early signs that your water heater may need help. Some of the more common red flags for possible water heater failures are visible corrosion. Corrosion is a sign that the water heater is breaking down. Whether the corrosion is around the water lines or on the unit itself, it's a sign of deterioration that can lead to weakening the system and contributing to the water heater failing. Water leaking, leaks from any joints, seals, or seams of your hot water heater, is usually an indication that there is a problem, potentially caused by corrosion. Hot water heaters are designed to be a closed system, and any moisture outside of that system is an indication that something's breaking down. Water leaking can get worse, not only be damaging to the water heater itself, but also potentially to the area and the things around it. Rust in the water. Rust in a water is usually a sign that the interior of the water heater is breaking down through corrosion. Lack of available hot water. Aging and poor maintenance can cause sediment to build up inside the tank in a way that reduces the tank's capacity. So chemicals, minerals in our water, they can contribute to that corrosion and breaking down the inside of the tank. The sediment and particulates can then start to build up, and then they reduce the available volume that can hold water in that tank, reducing the available amount of water that can be heated and used in your home. Rumbling noises. Water heaters are designed to operate consistently, quietly, and reliably. If your water heater is making unusual noises, rumblings, or vibrations, it's likely straining to operate correctly. Very often, rumbling can be attributed to a buildup of sediment on the bottom of the tank, which can lead to bigger problems. Any noises should be checked out. Ignoring these issues can lead to sudden failure of the water heater, cold water, and in some cases, tank rupture and water damage to the floors and carpet. The other downside to sudden failure is that you may have to schedule an emergency replacement with a plumber, which can be more expensive, and it typically limits your replacement options to the less efficient models that have those higher operating costs.
I always joke with my clients that when water heaters always fail like the night before Thanksgiving when your in-laws are on their way over.
Of course.
And then you just got to take whatever the plumber has on their truck. So
Exactly.
it pays to think ahead.
Whenever possible, folks should plan up front to be ready for replacing their water heater when there are signs of failure showing, which will also allow you the ability to plan for installing a heat pump water heater and not having to go with just whatever the plumber may have in stock at that moment. So there is the saying, if it ain't broke, don't fix it. It doesn't apply so much with water heaters. When we do see any of those signs of failures, it's a good time to start calling around, if you haven't already, to get quotes on high efficiency water heaters.
Be prepared.
And there are a variety of incentives to help offset those first costs for the heat pump water heaters. The 25C federal tax credit is available to anyone who pays federal taxes. It offers 30% of the installation costs, so that's both labors and materials, up to a cap of $2,000. The Homes Adhere rebates, which are funded by the 2022 Inflation Reduction Act, are being rolled out by each state individually. When those rebates are available, here will be available for folks making up to 150% of the area median income, and then households making up to 80% of the area median income can get a rebate of up to 100% of their installed cost, up to $1,750. Households in that 80 to 150% range can get a rebate of 50% of their installed costs, again up to that $1,750. The specifics around the eligibility, the timeline, the logistics, they're all going to be worked out at the state level and largely are still being determined as the states roll out their programs. The HOMES program doesn't have any income restrictions and doesn't call out specific technologies. Rather, it offers rebates based off the overall savings from energy efficiency improvements in a home. Heat pump water heaters could be a key part of an upgrade package seeking a HOMES rebate, given how much more efficient they are compared to other water heating options.
Right, you showed that data before, at 4 times more efficient. That's good savings.
In Virginia, there's also rebates available from 2 of the utility companies for customers in Dominion service territory who are replacing an electric water heater. It can't be a fossil fuel, it's got to be electric. They can get a rebate of up to $234. And then customers in Appalachian Power's service territory can get a $400 rebate for buying an Energy Star heat pump water heater. And so those rebates can stack on top of the tax credits. And then in Florida, Beaches Energy offers a $500 rebate. With all of these incentives, some consumers will be up to date and request a heat pump water heater knowing the incentives that are available to offset that first cost, but others won't know, and it would really be a disservice to not let them know about the incentives available so that they can upgrade to this technology. So now we'll talk a little bit about code and heat pump water heater installation information. Just to be clear, when we're talking about code, this is not a code class. We're not doing a deep dive into the plumbing code or the electric code or the building code. What we did want to highlight is potential code intersections with FEMA requirements. So if you are installing an electric water heater of any sort and it's going to be in a floodplain that's been identified by FEMA, you'll want to make sure that you confirm with the manufacturer that either the water heater can be safely inundated with flood water up to the height of the base flood elevation, or you'll need to elevate that water heater.
And that would apply with a gas water heater as well.
Yes.
For sure.
Yep, that's true.
Location selection is very important with heat pump water heaters. And there may be homes where there legitimately isn't a good spot to install one. If it's a smaller house and they've perhaps hidden what we would call a low boy electric heater, which are only about 3 feet tall, in a cabinet in the kitchen, you may not find somewhere that's appropriate to install one of these larger heat pump water heaters. As we discussed, there are heat pump water heaters where you can have a separate condensing unit that's separate from the storage tank, where you have a box out in the yard, but they do cost quite a bit more. Heat pump water heaters are heavier, so you want to make sure that the floor can support the added weight or make adjustments. If you have any concerns about proper installation, you can always look to some good references online, and this slide shows something from NREL's standardized work specifications. To select the best location for the heat pump water heater, determine its interaction between the heating and cooling equipment for the home. So you're asking, where does the space around the water heater get its heat? Should the unit be placed in conditioned space, semi or unconditioned space, maybe an attached garage? In hot climates, heat pump water heaters offer a net cooling benefit, while in cold climates, they will cool the area around it, which might be considered a penalty. Generally, homes in climates 1 and 2 offer this very valuable net cooling benefit. For climate zones 1 and 2, installation in an attached garage or conditioned space may be appropriate. Heat pump water heaters will not operate efficiently in a cold space since they tend to cool the space they are in. Installing them in a space with excess heat, such as a furnace room, will increase their efficiency. Adequate volume of air around the heat pump water heater is critical. Each manufacturer will have acceptable installation scenarios. Here's one example. In the first, we see the water heater installed in a room with a solid door. So long as that room has 700 cubic feet of air, this works. The next image shows an example with the volume of air less than 700 cubic feet, so a fully louvered door is needed. Essentially, this connects that room to the other and provides additional space from which the water heater can harvest heat. Next, we have a couple of scenarios that show ducting. Here we see a couple of scenarios that provide ducting to the heat pump water heater. In this example, the cold air being exhausted from the heat pump can be sent to another room or to outside the building. On the left, we see just the exhaust side hooked up. And on the right, we can see where there's also an intake duct where that water heater may be pulling in its air and essentially its heat source from another room or from outside.
All right, so now we'll go through an activity of where you might potentially locate a heat pump water heater in a sample home. So there's a lot to look at this image, and we'll explain a little bit of it. We're going to highlight the areas where potentially that heat pump water heater could be installed. We've got a garage, we've got a laundry room, and then we also have a closet, that big walk-in closet adjacent to the primary bedroom and bathroom. Keep in mind that we have 2 bedrooms on the right side and that there are 2 full baths. Each one of those is located next to one of the bedrooms, and then there's a half bath near the kitchen. Given what you've learned in today's class, where would you recommend installing a heat pump water heater? And once you figure out a location, how big should that water heater be based on the sizing calculations? And there is a slight trick, which is that you'll want to make sure that this table is showing the first hour rating, not gallons. So you'll need to then translate that first hour rating into a piece of equipment that can meet that. So Andrew, if you were tasked with installing a heat pump water heater in this home, where might you pick?
Well, we've got 2 bedrooms, so we can use that column. It's showing either 60 or 60, and then showing 2 to 2.5 bathrooms. So we've got 2.5 baths here. So there we go, 60 gallons.
Yep, and in terms of location, the garage is a great location in terms of not putting any cold air into the home. Heat is just going to be gathered from that garage space and the cold air will be expelled to that garage space. Downside is it's sort of far from the 2 main bathrooms, the bathrooms that are attached to each of the bedrooms. So you may end up with some customer complaints about just the length of time to get hot water over to those spaces. The laundry room is definitely a contender because there are not any real living spaces adjacent to it. You've got a bathroom on one side, dining room on another side. Noise isn't really going to bother anyone. That room being slightly colder isn't really going to bother anyone, and it'll be offset a little bit when somebody's running the dryer. So that's an option too. However, it's still sort of far from those bathrooms, but not quite as far as a garage. And then the primary closet, for length of time to get hot water, it's perfect. It's right next to both of those bathrooms, but likely nobody is going to want to either give up closet space for that water heater or have to listen to the noise. Though the noise in that space would at least be buffered from the bedrooms by the bathrooms and the closets. So 3 potential options, each with their pluses and minuses.
Well, here is a real-world example that I'm very familiar with. This is my home. I put in a heat pump water heater back in August of 23, and you can see there the original 1990, well, not original, but the house is very old, but there was a working 1996 electric resistance water heater. Now, the retail price for that new water heater was $1,699, which qualified for the 30% federal tax credit. And I'm going to go through some of the details about this to really break through to the value proposition here. So you can see there on the slide that that 96 tank still had the energy label on it, and it said, you know, on average you could expect it to use a little over 5,000 kilowatt hours per year. So here's the new heat pump water heater I put in. Now it's down in my basement, so I really think of that as an ideal location for it. It blows out cool, dry air. Hey, I was running a dehumidifier down there already to keep the moisture under control. So it's really kind of a perfect location. The modest noise and the cool air aren't a problem. And it's brand new, so it had an energy label. And here's the big difference here. A little over 800 kilowatt hours per year, again, compared to that 5,108.
It's an impressive difference.
It's fantastic. More than 5 times more efficient. Oh, and did I mention the tank is larger? So more hot water at a fraction of the cost. And at our local then current electricity rates, which have gone up since then, it's saving me over $600 a year. So yes, it costs more than 3 times for the device to install it. I'll earn that back in less than 3 years. So I consider this a really good investment. And it works great. I mean, it does the job. Again, it's a bigger tank. Well, those are the last of our slides. Here's another QR code where you can take a follow-up survey on the presentation we just gave. We really would appreciate your anonymous feedback to help us improve these presentations. Well, thanks for joining our presentation today. I'm Andrew Grigsby with Viridiant.
And I'm Sean Shanley.
And we wish you the best of luck installing heat pump water heaters.